Okay, so the next section is the analytic geometry section. And in the first question, we ask, in how many points can a straight line intersect a circle? Okay, so a straight line, if we have a circle, can intersect a circle in no points. So it is possible to not intersect it at all. Then it can, so let's draw a circle. Let's go here. Okay, so if we draw a circle, it is possible for a straight line to intersect the circle not at all. Okay, then it's possible for it to intersect the circle in 1 point, and then it's possible to intersect it in 2 points. So a straight line has 3 ways: in none, 1, 2, or 3. So in other words, in 1, 2, and 3. So the answer here is B, in 1, 2, or 3 points. Okay. Next, we ask, consider the circle with equation, and there's an equation. What is the coordinates of the center and the length of the radius? So the coordinates of the center is simply x minus p and y minus q. So it's the coordinates is 1. So to make it simple, I think everyone got that correct. Everyone that knew anything. So x minus 1 is equal to 0, and y plus 2 is equal to 0. You just take those brackets, make them equal to 0, and then you get x is equal to 1, or y is equal to -2. Okay, so that's the coordinates. That's not the coordinates. This is coordinates. That's the coordinates of the center. Okay, what's the radius of the circle? Well, the circle equation is, and what I should actually have done is I should have just given you this: x minus p squared plus y minus q squared is equal to r squared. Then p comma q is the center and r is the radius. Okay, now in our case we've got r squared is equal to 5, so the radius is equal to the square root of 5. Cool. Let's move on. Next we have, what is the equation of the line that passes through the center of the circle that has a gradient of 2? So we start with y is equal to mx plus c. But now we say, well, it has a gradient of 2, and now it passes through the center of the circle. So we substitute the -2 and the 1. Okay, plus c, and that gives us an answer: c is equal to -4. So our final answer is y is equal to 2x minus 4. That is the line that passes through the center of the circle. Find the points where the line 2.2 intersects the circle. So find the points where it intersects the circle. So I had, whenever I find the solution of two objects that intersect, two functions or graphs that intersect, I solve their equations simultaneously. Okay, so I have this and I have that. So to solve this simultaneously, I will have to substitute, or I can substitute y in this first expression with this. Okay, so I have 2x minus 4 plus 2 gives me -2. Okay, is equal to 5. And now it's just simplifying. I want to show you something cool though, that would make it easy to simplify this, and I can take out 2 as a common factor here. Okay, so take out 2 as a common factor, then I've got x minus 1. You could just multiply it out and solve the quadratic inequality, but let me be fancy. X minus 1 squared is equal to 5. So now I've got 2 brackets exactly the same with the same exponent and coefficients. So here I've got one of these brackets, there I have two of them, so in total I have 3x minus 1 squares equal to 5. Okay, which then can become x minus 1 squared is equal to 5 over 3. And this then becomes x is equal to the negative 1. I'm going to take the square root on both sides, so plus minus, taking the square root of both sides, and then x is equal to x minus 1. I add the minus 1, plus 1 on both sides to get that rid of that, so I've got x plus minus the square root of 5 over 3. 5 over 3. Good, and then if I have to find the y values, I just take this value. Now you can substitute that value into an equation if you want to, into your calculator and get the decimal answers, or you can just keep it like that and look how nicely it's going to solve here. So x minus 1, x is then equal to, I substitute it in here to get my y values. Y is equal to 2 times this, which gives me a 2 minus 4, so I get minus 2 plus minus the square root of 5 over 3. So there's my 2. So the one solution is 1 plus minus the square root of 5 over, not 1 plus minus, 1 plus the square root of 5 over 3, and then the y value is the same, it's just minus 2 plus minus this, not plus minus, plus square root of 5 over 3, and 1 minus the square root of 5 over 3, comma, minus 2 minus the square root of 5 over 3. That's it. Okay, so it's fairly easy. You could have used your calculator. Maybe I'll make it look complicated, but it's not really. Okay, on the Cartesian plane, what is the relationship between a tangent line to a circle and the line passing through the center of that circle and the tangent point? So if that's a little bit confusing, then draw it for yourself what they're talking about. So they're asking, what is the relationship between a tangent line to a circle and a line, so there's a tangent line, and then a line through the center of the circle that passes through the tangent point? And we know what the relationship is, hopefully. It is they are perpendicular. They are perpendicular. Okay. Next question. If the gradient of the tangent to a circle is a over b, what would be the gradient of the line passing through the center of the circle and the tangent point? So in other words, if this one's gradient is a over b, what would this one's gradient be? Okay, so if you didn't know, the gradient of the tangent times the gradient of the radius is equal to -1. So if the gradient of the tangent is a over b, then multiply that by the gradient of the radius and get -1. So I want the gradient of the radius, so I'm going to multiply both sides with the reciprocal, okay, so that I can cancel it away. So multiply this side with the reciprocal as well. So the gradient of the radius is -b over a. So the point just being is that whenever I have a gradient like 1 over 2, the perpendicular gradient would be -2 over 1. If it was 3 over 2, the perpendicular gradient would be -2 over 3. In other words, the fraction swaps around and gets multiplied by -1. Okay, and then the next question, which was also fairly simple question. In the sketch below, AB is a tangent at point B. AB is a tangent at point B to the circle with its center at the origin and a radius of 4. So here's the center at the origin and a radius of 4. A is the y-intercept of the tangent. Okay, the length of AB, the tangent point, and the y-intercept is 3. Give the equation of the circle. Okay, so the equation of the circle is simple enough. The equation of a circle is x minus p squared plus y minus q squared is equal to r squared. Now we just substitute the center, which is the origin. So it's x minus 0 squared plus y minus 0 squared is equal to, and then the radius we said was 4. So here we must have 4 squared, which is 16. Or you could have put 4 squared, that would have been correct. Okay, and then finally, last question. Only there's a few more questions, sorry about that. Okay, the numbers 6, 8, and 10 together is called a Pythagorean triple because 6 squared plus 8 squared is equal to 10 squared. Okay, 6 squared is 64, 6 squared is 36, 8 squared is 64, 10 squared is 100. And so 36 plus 64 is 100. Give another example of a Pythagorean triple. Okay, and the most common one is 3 squared plus 4 squared is equal to 5 squared. You'll notice that's even just half of what was already given to you. So that was really a very easy question, but it was given to let you see that that a Pythagorean triple are numbers that can make up a Pythagorean triangle, because the 3 squared plus 4 squared gives me 5 squared, so that the next, without any calculations, give the coordinates of A. So here you should have just noticed, oh well, since this is a tangent line, this is a right-angled triangle, 3, 4, that must be 5. Okay, so the coordinates of A is 0, 5. Okay, now consider 3 points. So here we have 3 points. Complete the following. Now they say about these 3 points that in these 3 points at angle B there's a 90-degree angle. So AB is perpendicular to BC. AB is perpendicular to BC. Complete the following. The gradient of AB times the gradient of BC will equal -1. Why -1? Because they are perpendicular. So the gradient of AB times the gradient of BC will equal -1. Now this is helpful for the next question, because now we ask find D. So what must D be for this to be true? Well, we can now just substitute into, because all we need is an equation. So AB, let me just get those values. 15, 5, 3D, and 9, 12. So we have 15. A is -15 and 5. B is 3 and D. And then C is 9 and 12. This is -3. And then C is 9 and 12. Cool, so we have that AB is y of A minus the y of B divided by the x minus the y as xa minus xb times, and then on this side again the same thing, I subtract my y's, so D minus 12, and then I subtract my x's, negative 3 minus 9. This must equal to negative 12. And so when I simplify, you'll see I get 5d minus d minus 12 over, and then on this side I get negative 12 times, and on this side I get negative 12. So I get positive 144 times negative 1. So if I multiply that, I get 5d. If I multiply it out, I get 5 times d minus d squared plus 12d, and then minus 60. 5 times 12 is equal to, and then here I get 144 multiplied that side gives me negative 144. And so in total that gives me d squared 5 and 12 is 17. So minus 17, because I'm dividing with that, minus a plus 166, plus 66, plus 144, no, that's going to be negative 144 when it comes, when I divide everything with a negative. So that is minus 60, so it's 84. So plus 84 is equal to, just confirm, 84. It should be negative 84 is equal to 0. Okay, so now I need to get two things that I multiply to get 84, and when I subtract, I get 17. So it is d minus 21 d plus 4 is equal to 0, and so d is either equal to 21 or d is equal to negative 4. Okay, two solutions. Good. Now let's get to the last part of this question, and this part asks me, says, okay, find the equation of the circle through these 3 points. Okay, now what you should notice is that we have a 90-degree triangle. Okay, so a circle through a 90-degree triangle. So I've got, let's draw something. Okay, so I've got whatever it looks like. Doesn't really matter where these points are, but if I have a circle, let's try a little bit better. If I have a circle through a 90-degree triangle, it's not going to work. Let's try again. Also not going to work. Okay, let me do it by hand. Okay, if I have a circle through a 90-degree triangle, the point is that if I know my geometry, then I will know that this is the center line, the center or the diameter. That is the diameter. Okay, because the angle at the center is twice the angle at the circumference. If the angle at the circumference, then if there's one angle of a 90 degrees, then the side that's opposite that angle must be a diameter or diameter. Okay, so I know that AB, that line AB is the diameter. The midpoint of that diameter must therefore be the center, and the length of it divided by 2 must be the radius. So I've got negative 5 negative 15 comma 5. So it's not AB, sorry. It's not AB. If B, it's AC. So negative 15 and 5 and 9 and 12. Negative 15 and 5 is A. So this is A, B, C. Negative 15, C is 9 and 12. And so now if I find the midpoint of that, the midpoint is those two added together, the average between the x's. So that added together gives me negative 6 divided by 2 is negative 3. And then those two added together is 17, so it's 8.5. Okay. Now, what is the distance? The distance of AB divided by 2. That would give me the radius. So I take the distance, which is negative 15 to 9. That distance is negative 15 minus 9, which is negative 24 squared. Negative 24 squared plus, and then 5 plus 5 minus 12 is negative 7 squared, and then that answer divided by 2. So what do we get? 24 squared. 24 squared should be 144 times 4, 567. 76 plus 49. Okay, it's equals 625. That actually does have is a perfect root. So 25. 25 divided by 2 is 12.5. Okay, so there we go. My center of my equation of my circle is x minus 3 is plus 3 squared plus y minus 8.5 squared is equal to 12.5. Excellent. And let's see how we're doing on time. Yeah, in 20 minutes with explanations and hiccups. So definitely you should be able to do this in the time given for the test. Great. Well, thank you very much. Let me just show you how marks were to be allocated for this. One is allocated for recognizing the, and this is a problem solving step question, a level 4 question, because there was a problem to solve. How can you do this? How can you find the equation of a circle through 3 points? And it was that you had to recognize the diameter. Once you have the diameter, a point was given for finding the center, finding the length, and then putting all of that together in a final answer. So well done. Thank you for giving this some attention. Hopefully you learned something, and we'll see you in the next video.